So before we go any further, I just want to quickly check that you guys remember how to factorize using your CAS. So in calculator mode, factor is under algebra in the menu. So you're pressing 3 and next to solve here, we click factor and we just type in whatever expression it is that we are asked to factorize. So let's do one that we've done before. 3 times y cubed minus 81. Close the bracket, hit enter, and it factorizes it for us. So don't forget that technique when you're going through these exercises. So we'll do some examples of grouping. Now grouping we use when we've got expressions that we wish to factorize that have more than one per numeral. So an example in your textbook. So we're asked to factorize this expression. Now what we can observe is that if we look at these three terms and we rearrange the expression, by grouping these three together, we can see that that is in fact a quadratic. So if we leave the m for the moment, and we take out minus 1 as a common factor for the last three terms, and we factorize, so we notice that 2 times 36, oops, I'm missing in here, 6 times 6 gives me 36, and 6 plus 6 gives me 12, or we can notice that that's a perfect square either way. We get n plus 6 times n plus 6 when we factorize that quadratic. We can actually go a little further here because what we've got is the difference of two squares. We've got m squared and we've got m plus 6 squared. To factorize, that becomes m minus n plus 6 m plus n plus 6. So a second example for grouping from the textbook. So in this one, instead of grouping 3 and 1 like we did in the previous example, we're going to group 2 and 2. So we'll have a look at the first two terms and the second two terms. From the first two terms, we can take out p squared as a common factor, so that we're left with p and 2. From the third and fourth terms, we can take out minus 4, so that we're left with p plus 2. Now when this happens, we've actually got a common factor for both the first term and the second term now. This p plus 2 is in both of those terms, so we can take that out. Now we can go another step further there because this last bracket here is in fact difference of two squares, so we can factorize that further. and it becomes p plus 2, p minus 2. So we rewrite that because the first two brackets are the same as p plus 2 squared, p minus 2. Okay, so for higher order polynomials, now remember that, first of all, try questions 5 and 6 from exercise 1.2 before you do this next bit. I think question 5A is wrong in the textbook, so skip it. So back to polynomials. So if we remember that polynomials are usually either quadratics, cubics, quartics, or linear equations. They deal with whole order powers like 2, 3, or 4 powers of x, and they usually have some coefficient. So quadratic is in x squared, cubic is in x cubes, and quartics are in x to the power of 4. So we remember back to when we were factorizing and using long division and that sort of thing, and we use this thing called the factor theorem. So a polynomial, p of x, has a factor x minus a if and only if p of a equals 0. So that is if a is a root or a solution of the polynomial. So let's do an example so that makes sense. So we want to factorize this quadratic, x to the 4 minus 4 times x cubed minus x squared plus 16x minus 12. And we want to see whether x minus 0 is a factor. So so if this is p of x, sorry. So what we're going to do is put 0 into our equation to find p of 0. So putting 0 in there, we get 0, minus 0, minus 0, minus 0, minus 12. So that's just minus 12. So our theorem says that if x minus 0 was a factor, then p of 0 would have to equal 0, but it doesn't. P of 0 equals minus 12. So then x minus 0 is not a factor. So let's try another number. Usually we'd try at 0, and then you would try 1, then you would try minus 1, then you would try 2, then you would try minus 2, until we find a factor. So we'll try p of 1. So putting 1 into the expression, we get 1 to the power of 4 minus 4 times 1 cubed minus 1 squared plus 16 times 1 minus 12. So in other words, we have 1 minus 4 minus 1 plus 16 minus 12. And if we equate that, the 1's cancel, and we see that minus 16 plus minus 4 plus 16 minus 12 equals 0. So therefore, x minus 1 is a factor. The minus comes from the fact that if x is 1, then x minus 1 is a factor. So don't forget to change the sign there. So once we have a factor, if you recall back, then we need to factorize the entire expression, we need to use long division. So we're using the factor that we just worked out, x minus 1. We write that on the outside of the division symbol, and we write the polynomial which we are dividing on the inside of the division symbol. So the first thing we do, we look at the first term of the polynomial and we work out what we need to multiply x by to get x to the power of 4. So we need to multiply x by x cubed to get x to the power of 4. Next step is to multiply the divisor by x cubed. So x cubed times x is x to the power of 4, which is what we wanted, and x cubed times minus 1 is minus x cubed. Then we subtract. So x to the power of 4 minus x to the power of 4 is 0, so that disappears. Minus 4x cubed minus a minus x cubed is the same as plus x cubed. So minus 4x cubed plus x cubed is minus 3x cubed. Then we bring down the other terms in the equation, because essentially what we're doing is if these are zeros after that, we're subtracting 0, so they just come straight down. Now we look at this term. What do we need to multiply x by to get minus x cubed? So that would be minus 3x squared. So we take the minus 3x squared and multiply the divisor. So x times minus 3x squared is minus 3x squared. Minus 3x squared times minus 1 gives us plus 3x squared. And we subtract. Minus 3x squared minus a minus 3x squared is 0, which is what we wanted. Minus x squared minus 3x squared is minus 4x squared. And bringing the other terms down. So now we look at the minus 4x squared. What do we need to multiply x by to get minus 4x squared? It would be minus 4x. Writing that up the top. Minus 4x times x. Minus 4x squared. Minus 4x times minus 1 is plus 4x. And we subtract. 16, so the 4x is cancelled, and 16x minus 4x is 12x. Bring down the 12. What do we need to multiply x by to get 12x? Is 12. Multiplying through 12x minus 12. And when we subtract those, we get 0, which is what we wanted. Remember that if we don't get 0, then something's gone wrong in our long division. Right, so now we have a cubic factor and our first linear factor that we discovered earlier. So we have x minus 1, x cubed minus 3x squared minus 4x plus 12. Now we have to repeat the process all over again because we need to factorize that cubic. So we need to find a factor of that cubic. So again, we can trial and error. We know that 0 isn't a factor because we tried that before. We tried 1. We could try minus 1, but I'm going to try 2 just because I know that works. So if we we'll say at this time q of x is equal to our cubic. And we're going to trial, oops, not p. We're going to trial x equals 2. So we'll put 2 into our cubic. Two cubed is 8. Minus 3 times 4 is minus 12. Minus 8 plus 12. And we can see straight away the 8's cancel, the 12's cancel. So that's 0, which means that x minus 2, remember, if we trialed x equals 2, then the factor is x minus 2. Great, so we're going to have to do long division of this cubic. Long division of the cubic by x minus 2. We need to multiply x by x squared to get x cubed. Multiplying x squared by x, we get x cubed. X squared by minus 2 is minus 2x squared. Subtracting terms, x cubed minus x cubed is 0. Minus 3x squared minus a minus 2x squared is the same as plus 2x squared. So that's just minus x squared. Bringing down the other two terms. We need to multiply x by minus x to get minus x squared. Minus x times x is minus x squared. Minus x times minus 2. So up to here, minus x times minus 2 gives us positive 2. Subtracting, first terms go away, the second term is minus 4x, minus 2x is minus 6x, plus 12. We need to multiply x by minus 6 to get minus 6x. Minus 6 times minus 2 is plus 12. And when we subtract those, we get 0, which is what we require. So now we're down to the original factor that we found, which is the x minus 1. Now we've just factorized this cubic and it became x minus 2. And the quadratic expression that's up here, x squared minus x minus 6. We can hopefully factorize this quadratic expression in our heads by trial and error. So we need two numbers which multiply to give negative 6 and add to give negative 1. They would be x minus 3 and x plus 2. Minus 3 times 2 is minus 6. Minus 3 plus 2 is minus 1. And so now we've factorized that original quartic equation. So x to the power of 4 minus 4x cubed minus x squared plus 16x minus 12. Once we've factorized it, it just equals this expression that we've got down here. Okay, so as soon as you've done that, pause the video and try questions 7 and 8 from the textbook. Okay, so moving on from factorization, the next step is when we fully solve an equation. So the first step is always to factorize. We should sort of recognize that the order of the polynomial will tell us how many solutions there are. Now remember, solutions is where the graph of the function touches the x-axis. So for a quartic, we can have situations up until when there's 4 possible solutions for where the graph can cut the axis. Of course, we can get quartics that are like flat bottom parabolas and they would only have 2 solutions. So the maximum number that we can get is 4 for a quartic. For a cubic, the maximum number is 3. But again, we don't have to have 3. We can have just 1, even if we just have an inflection point style cubic. So let's go through some examples. So when we solve a polynomial, the first thing that we want to make sure is that we have one side of the equation equaling 0. So once we've got one side of the equation equaling is 0, the next step is to factorize. So this equation's already been factorized. So it would have been factorized by first finding a common factor, not common factor, sorry, a factor of the expression, and then use long division to find the quadratic factor and then factorize the quadratic factor as we did earlier. So once we've got our factorized expression, then we can use the null factor law. And the null factor law says that if we have an equation that equals 0 and it's in factorized form, that one of these factors or all of these factors should equal 0. So in other words, we've either got x plus 1 must equal 0, or x plus 5 must equal 0, or x minus 3 equals 0. And when we solve each of those individual equations, we get x equals minus 1, x equals minus 5, and x equals positive 3. So of course we can jump this step here and we can just pull the solutions straight from the factor form, but we've got to remember that change of sign. So plus 1 becomes minus 1, etc. Okay, the other thing to note is that instead of completing the square, when we're solving equations, we can use the quadratic formula. So quadratic formula, of course, number in front of the x squared is a, number in front of the x is b, and the constant by itself is c. Have to be, before we proceed with the formula, however, we have to make sure whether there actually does exist any solution. So the expression that's under the square root sign, this b squared minus 4ac, remember that that's called the discriminant. And if the discriminant, so if we work out that little bit, and if it's greater than 0, there are two solutions. If it equals 0, there's only one solution. And if it's less than 0, there's no real solutions. Because of course, we can't have the square root of a negative number. So that's why if the discriminant is less than 0, there's no real solutions. So let's just work out what the discriminant is before we proceed with the question. So the discriminant is b squared minus 4ac. From the equation, that's going to be 2 squared minus 4 times 3 times 4, which is 8 minus 4, 8, sorry, which is 4 minus 48, which is minus 44. So the discriminant is less than 0, so there's no solutions. Also, very important to make sure that you're actually writing or making that statement, there are no solutions. Another example, there is some questions like this which you're asked to factorize and solve within the exercise. Sorry. Where you actually have to remember the method of substitution. So if you have a look at this, it looks a little bit like a quadratic, except in fact what we've got is a quartic. So only 3 terms. So what we can do is make the substitution, let s equal a squared. And when you do that, this becomes 2s squared minus 5s minus 3 equals 0. And you can either use, you could use the quadratic formula to find the solutions here, but in fact it's going to be better, let's just to use the cross method, because if we have a look here, oops, not x, it was s. Multiplying that cross there, get s and minus 6s, which gives us minus 5s. So we're all good. So that we can just factorize that as 2s plus 1 s minus 3 equals 0. Substituting back that s equals a squared, we get 2 times a squared plus 1 and a squared minus 3. This last expression here is in fact difference of 2 squares if we consider that that's minus the square root of 3 squared. Okay, now we can apply the null factor law. Or we could try to factorize this quadratic expression further, and you could find the discriminant. So remembering that that's the same as saying 2a squared plus 0a plus 1. So if you find the discriminant there, we've got b squared 0 squared minus 4 times 2 times 1. So the discriminant there is minus 8. So for that part of the expression, there are no solutions. However, here and here, we do have solutions. So we have a equals plus or minus the square root of 3. Could have done that slightly different with this expression here. Could have used the null factor law and let that equal 0. Oops, sorry. Let that equal 0. Taken the 1 over the other side. Divided by 2. And then recognize that there's nothing here that we can square that couldn't give a negative number. So there's no solution there. No real solution. I should write that. No real solutions. Which I did write up here, no real solutions. Because if we were going into the complex number system, there would be solutions, but we don't deal with that in maths methods. So you can try questions 9 and 10 from exercise 1.2, and then we'll continue on with equality of polynomials. Okay, so quickly to finish this exercise off, we have that if 2 polynomials are equivalent, so equivalent means equal, then the coefficients of each power are also equal. Each power of x are also equal. So that just means if we've got some polynomial here, and we'll use this symbol here, oops, the symbol with 3 lines, that just means equivalent. Then it means that the coefficients of x cubed, so 3 and 2b must be equal, coefficients of x squared, 2 and 4a must be equal, etc. And we can use that to find the variables within the question. So we can use it to find the variables b, a, c, and d. So in other words, we've got 3 must equal 2b, 2 must equal 4a, 5 must equal c, and minus 3 must equal minus d. So looking at this and solving for b, so if we divide both sides by 2, we get b is equal to 3 divided by 2, or 3 halves. The second equation here, if we divide both sides by 4, we get a is equal to 2 divided by 4, which is the same as a half. C here is just equal to 5. Multiplying both sides by -1 here, we get d is equal to 3. And thus, we found the values of a, b, c, and d. Slightly more complicated example. This time we need to find the variables m, n, p, and q. Again, we equate coefficients. So we've got m in front of the x to the power of 4, and we've got minus 2 here. So m must equal minus 2. Coefficient of x cubed. Don't forget the negative sign out here. So coefficient of x cubed is minus n minus 3. And on the other side of the equation, the coefficient is minus 2. Coefficient of x squared is m plus p. And on the other side, the coefficient is just 1. Remember that there's an invisible 1 here. Coefficient of x here is p plus q. On the other side, we don't actually have an x term, so its coefficient must be 0. So this here must be equal 0. All right, so straight away we can see here that m equals minus 2. That's done and dusted. So we can use that fact that m equals minus 2 in this equation down here. So let's put minus 2 in for m. Hey, Georgia. Putting m in here, we have minus 2 plus p equals 1. And solving for p by adding 2 to both sides, p equals 3. In this second equation, let's multiply through by -1 first. So we end up with negative n. Actually, I might not do that. We just might multiply both sides by negative so that we end up with n minus 3 equals 2, and then add 3 to both sides, we get n equals 5. We found what p is here, so if we substitute p in here, we should be able to work out what q is. So in other words, we've got 3 plus q equals 0, subtracting 3 from both sides, and we find that q equals minus 3. Okay, so we found what m, n, p, and q is. So now you can try questions 11 and 12 from the textbook. Don't forget that you've got the solutions manual. So, use that as to the best of your ability. Now, what I would like you to do, so if you've done all the questions so far through the screencast, that means that you've done all the questions that are in green in the textbook. So there's always those two sections. There's the green section that you've got to do without your CAS. Now the next section, which is all the blue questions and those master questions, you should do them. If you've got time, you should be doing all the questions in the textbook for Year 12. However, if you don't have time, make sure that you're doing those green ones. And remember that when you do the blue ones, you're usually allowed to use your CAS. So don't go, typing heaps of stuff in. So some of the commands that you can use are solve, linsolve, and factorize. I can't remember if there was any systems of equations to solve in here, but I'll go through some examples now. So remember, if you are asked to solve an equation, so if we do one of the ones that we did before, so for instance, you could go menu, algebra, solve, and we could type in the example that we did previously, which was 2 times a to the power of 4 minus 5 times, don't forget your time symbols in. Sometimes it doesn't like it if you don't put your time symbols in. It was, a to the power of 2 minus 3. Key thing here, you've got to tell it what variable you're solving for. So we're solving for a, so you put a in there. Hit enter. Oops, what have I done? Oh, I haven't put equals 0. Two key things. To solve, we need an equality. So we need to say what it equals, and then we need to say what it's solving for. So it equals 0, we're solving for a, and now we get the two solutions that we found earlier, -3 and square root of 3, or square root of 3 and square root of -3. Negative square root of 3 and square root of 3. So don't forget, I don't think for this exercise you have any systems of equations, but we'll need it shortly, and that's also in there and we were solving systems of equations, and you can choose whether you're solving a system of equations or a system of linear equations. So that's linsolv, and you just write how many variables and how many equations that you've got. We'll come back to that next lesson.